Let's look at number 12 now. So determine the radius and interval of convergence for each series. So this is going to be a little bit painful, but got to look at it. It's important. So let's take a look. X minus 1 to the n over 2n minus 1. So we look at that one first. So remember, these now are power series. X minus 1 to the n over 2n minus 1. And so now here I need to use a test, either ratio or root. And let's try, root doesn't seem to do much because it'll mess with the x minus 1, but I don't really care about that too much. And it's going to make the 2n minus stuff weird, so we use ratio test here. When in doubt, use ratio test. So an is x minus 1 to the n over 2n minus 1. An plus 1 is x minus 1 to the n plus 1 over 2 times n plus 1 minus 1, which is also, by the way, x minus 1 to the n plus 1 over 2n plus 1. And now we look at the limit as n goes to infinity of an plus 1 over an, but that's the same thing as x minus 1 to the n plus 1 divided by 2n plus 1 times 2n minus 1 over x minus 1 to the n, because that's an plus 1 divided by an. If I want to divide by a fraction, I multiply by the reciprocal. But then this is the limit as n goes to infinity of, write it this way, x minus 1 times x minus 1 to the n. Pop one of the powers off. X minus 1 to the n times 2n minus 1 over 2n plus 1. So these cancel, and I'm left with limit as n goes to infinity of x minus 1, and then this limit, but the limit I have circled there is equal to 1. So this is equal to the limit as n goes to infinity of absolute value of x minus 1, which is just x minus 1. So for the series to converge, I need x minus 1 to be less than 1. So the radius of convergence is equal to 1. And that's purely because of this number right here. If this was a 2, the radius would be a 2. If it was a 7.6, radius would be 7.6, and so on. But it's 1, so the radius is 1. So this says minus 1 is less than x minus 1 is less than 1. Add 1 to every side. 0 less than x less than 2. And now what do? We need to test the endpoints. So I is equal to 0 to 2, but I don't know about the endpoints just yet. And I'm going to circle that because it's going to be our answer. But now let's plug in 0, see what happens. At 0, we have the sum n equals 1 to infinity. If I plug in x equals 0, I get minus 1 to the n over 2n minus 1, which converges by the alternating series test. So I'll leave it to you. Check. The limit is 0. And the function is decreasing, but we've done this twice before already. You can show it the easy way. If I plug in n plus 1, it's going to be less than if I just plugged in n. So that converges. So the 0 has a bracket on it. At 1, we have the sum n equals 1 to infinity, 1 over 2 minus 1, which diverges by limit comparison test as if I compare it to a series which diverges, 1 over 2 minus 1 over 1 over n, this would be equal to 1/2. But 1/2 is bigger than, or yeah, 1/2 is between 0 and infinity. So by the limit comparison test, they both either converge or diverge. I know the bottom one diverges, so I get an open interval. So as an example where you have one that holds, one bracket that holds, one that doesn't. And that's 11, or that's 12a. So now we go to 12b, and we have sum n equals 0 to infinity of n squared times x to the n. And so you should probably thinking, oh, this looks like it's going to diverge. But let's take a look. Ratio test doesn't make sense, so let's use limit as n goes to infinity. An is n squared times x to the n. An plus 1 is n plus 1 squared, x to the n plus 1. So we get n goes to infinity, an plus 1. So for once we don't have a fraction, x to the n plus 1 divided by n squared, x to the n. And so we get the limit n goes to infinity of n plus 1 squared for n squared times x, right? Because x to the n is x times x to the n. If I move this, yeah, so I get 1 times the absolute value of x. Okay, so this actually will converge as long as x is less than 1. So I couldn't fully trust my instincts there. So as long as the absolute value of x is less than 1, we're good. And so now we tested the endpoints. So we have minus 1, less than x, less than 1. But we look at these two sums. Sum start at 0. So here I have a feeling that it's not going to converge at either endpoint. So I'm going to plug in minus 1 first. And I get n squared times minus 1 to the n diverges as the limit as n goes to infinity of n squared isn't even 0. Similarly, this sum is also going to diverge. And in fact, it's even worse. So I get I is equal to minus 1 to 1. Okay, and that's our answer to 12b. How much space do I have left and what's the next problem? Okay. So let's do 12c. Sum n equals 2 to infinity n times x to the n over n factorial. So now we use ratio test again, because I see a factorial. And so I look at the limit as n goes to infinity of, well, I need to know what my an and an plus 1 are. So an is n times x to the n over n factorial, n plus 1, x to the n plus 1 over n plus 1 factorial. I could cancel that n actually in both cases, which is kind of funny, but I'll leave it. So an plus 1 is this guy over n plus 1 factorial, then multiply by the reciprocal of this guy, n factorial over n x to the n. So I have the limit as n goes to infinity. What's the normal trick? Put similar terms over each other. N factorial. And I have n plus 1 factorial, so I'm going to rewrite it in this way. Times x to the n over x to the n. Magical cancellation land. This is like Christmas, where you get to cancel a whole bunch of stuff. This thing here, the limit's going to go to 1. So this is the limit as n goes to infinity of x over n plus 1. So I think about it, this x is just some fixed number. So this limit is equal to 0. In other words, the series converges for all x, right? Because no matter what x I pick, if I take this limit, I'm going to get 0. So r is equal to infinity, and I is automatically minus infinity to infinity. Remember, infinity is not a number, you can't plug it in. So you like to see these because they're quick and easy. And that's how you do number 12.